so we're back talking about section 10.2. We're talking about simple interest, and we discussed in the previous video that simple interest is affected by three factors: the principal, how much you borrow or how much that you have saved in a savings account; two, the interest rate. The bigger the interest rate, the more interest you're going to pay on that; and then three, the time. The longer the time, the more interest you pay. So those three factors directly influence the I. So I equals principal times rate times time. All right, so moving on with some problems. We're on number 8, following along in your note packet. It says another type of loan is called a discount note. If your directions in your problem say it's a discount note, that means they're going to take your interest up front. So if you take out a $700 loan and it says it's a discount note, that means whatever the interest that you owe, they subtract it, and they may only give you $650. So they take the interest from it beforehand, before they hand you the note, the principal. All right, so our example number 8, a bank discount note. So Julie Jansen borrowed $3,650 from her bank for 8 months. The bank discounted the note or the loan at 7.5. So we do our I equals PRT as always. So Julie has borrowed principal of $36.50. The rate was 7.5, so we make that 0.075, and the time was 8 months. So that is assumed to be in years unless otherwise stated. If the rate is a yearly rate, and again, unless it states otherwise, it is, then the time should also be in years. So, sorry about that. So 8, to change it to years, since 8 was months, we divide that by 12. So to change months into years, you divide by 12. So punch that on your calculator, you get $182.50. So that's how much interest she owes on her $36.50 loan. So since it's a discount note, they're going to subtract her $182.50 right up front. So, okay, that was the answer to A. So B part is how much do they hand her in money. So they take her amount that she wanted to borrow minus the interest that she owes, and what she actually gets is $34.6750. So you have to ask for a little more, I guess, if you're going to do a discount note to get what you really, if you needed $36.50. But anyway, that's the answer to B part. How much did she receive from the bank? Again, they keep your interest up front in a discount note. So on C part, they ask us, well, really then, what was her interest rate? That makes her interest rate a little higher than it might seem. You know, this said it was a 7.5 interest rate, but that's assuming they gave her $36.50. And our calculations are correct, that's fine. But C part is asking, think a little deeper about this. Really, what was the effective rate she had to pay? Because, you know, they didn't give her all that money up front. So recalculate it on C part and use this $34.67 as the principal, how much she really received. And we're going to see what rate does that make that. And the time was 8 months, so that's still solid. And how much interest she paid, that's what we figured out in A part, was $182.50. So to work C part, we take the effective amount that they actually gave her, the principal that the bank gave her, and we're going to figure out the rate, what rate that would make that in actuality. And then the time is still 8 months, and the interest is what we figured out in A part. So we're just going to do this problem again with these new numbers. So, you know, whenever this is worded this way, you've got principal, rate, time, like the rate's in the middle of it. You can go ahead and jump over that and multiply the parts that you see together, because, you know, in multiplication, you can multiply in any order. It's the same answer. So you go ahead and take this times this. So do that on your calculator, and you should get, I have 2311.6 repeating. Now, I recommend that you don't round until your very last step. If you do some preliminary rounding, like you round within the steps before you get to the end, you could have just a penny or so off. It can mess up your calculation. So I recommend you just keep this number in your calculator. The .666 is repeating, so keep that active in your calculator. Or if you're going to round, keep like 4 places. Keep 6, 6, 6, 6, maybe 7. But don't round to just 67 cents there, because it could mess up your final answer by just a little bit. So when we divide out this 0.6 repeating to get that to cancel and get R alone. then we divide on this side. Now you might be wondering, how do I keep that answer from being rounded if I'm going to do that, on my calculator? Well, most calculators have an ANS button. The answer button, it keeps your last calculation. So one way to do it would be after you get this 2311.66666, you probably have a 10-digit calculator, so it keeps 10 digits. It'll keep, what would that be, like 6 of those sixes. And then it's still wrapped around your calculator. It repeats and just keeps going. Well, anyway, if you just take that calculation and then you go to the next line on your calculator and do 182.50 divided by, because you need to divide it by and have that in as the under it, the divided by part or the second part of your calculation, you can pull that answer up by hitting the ANS button. On a lot of calculators, it's a second function. You might see it written in yellow or something over top of a key. Sometimes it's over the minus sign. So look for that. You may have an answer button that will kind of help you out with this, and that keeps it more exact, more intact with all the sixes without you having to write down 6, 6, 6, 6, 6, a bunch of times. So try that if you haven't before. Do 182.5 divided by, and then have it pull up the last answer, and it keeps that in more perfect form. Okay, so anyway, then hit equal. Regardless, your final answer should be, you get 0.07897 and 10-digit calculator, so you'll have maybe more there. But then we need to change it to a rate. Again, whenever you're doing a rate, we have to move our own decimal point. So it's 7.8947, whatever. So depending on what the directions say to round to, I've been kind of rounding to the nearest 1/10 of a percent, but do watch your directions in your homework. It could be 100ths of a percent or any other, or full whole number percent. I'm going to do 1/10 of a percent, so that 9 will round that up, and I'll have 7.9% for my final answer on number 8. All right, number 9. Ken wishes to purchase a new racing bike, but does not have the $2,000 purchase price. Luckily, the bike shop has 2 payment options. With option 1, Ken can pay $1,000 down and then pay $1,150 in 6 months. With option 2, Ken can pay $500 down and then pay $1,700 in 6 months. Compare these options and figure out who has the better deal interest-wise, who has the lowest interest rate there. All right, so number 9. Let's talk about option 1. Option 1, we got this $2,000 bike. We had $1,000 of it, evidently. That would be a factor in the decision making here as well. So we were able to pay $1,000 down on it. So we're only taking a loan for $1,000, and it says that you can pay it off in 6 months, and they're going to charge him $1,150, which means he's going to get interest of $150. All right, so you can read through that and kind of find all the players in your formula here. We know he's paying $1,150 is what they ask him to pay back, and he only owes $1,000. Remember, so that means $150 interest that they're charging him for the use of his money. All right, the principal is just the $1,000 he owes. The rate is what we're trying to figure out. And how long was that? 6 months. So we're going to call that half a year, or 6/12. So this would be our calculation to figure out our rate. We go ahead and take 1,000 times a half, which is 500, times the R equals 150. So to solve, we're dividing by 500 on each side. And then R equals, do your calculator, 150 divided by 500, which comes out to be 0.3. And then as a rate, we go to right. So that's a 30% interest rate. It didn't seem like it was such a big amount, but it actually comes out to be quite a bit of interest, a big interest rate, 30%. For option 2, Ken is only paying down $500. So he has his $2,000 bike. He pays down $500 of that. So his loan is going to be for $1,500. And they're going to ask him to pay back, what was it, $1,700. So we have all the information to do I equals PRT. So his interest, is $1,500 he owes. They're going to charge him $1,700. So that means he's paying $200 interest. Let me get this out of your way. $200 interest, and he borrowed $1,500. We don't know the rate, and it's again half a year, 6 months, or half a year. So we multiply the 15 times the 1/2, jumping over R there, you can do that, and that's 750R equals 200. Then to solve, we divide by 750 on each side. That will give us our interest rate for this deal, and it comes out to be 0.26 repeating. When we go to right, that makes 26.6 repeating. To the nearest 1/10 of a percent, it'd be 26.7%. So actually, this one won. This is a little better deal for us, even though it seemed like you paid a little more interest on it, the $200 opposed to the $150. It actually worked out to be pretty small because it was on a bigger principal. So because you paid on $1,500, so it wound up being a little better deal. So option 2 would be your final answer on that one. All right, then the last part, there's some reading here. Let's talk about this, partial payments. So we're saying that you could make some partial payments. Say it was a $2,000 loan, and you came in, you paid $500 after maybe a month, and then you came in another month and paid them, say, another $200. You could pay a little bit each month, and what they should do is recalculate it each time that you pay down a little bit on your loan. So this is actually really helpful information. It says when you do partial payments, it's wise to pay down the principal as much as possible, because the principal is the big player in this. If you have a high principal, you're going to have more interest. That's just how that would work, and of course higher interest rate and longer time. So the more you can pay it down, the better. So this will greatly reduce your overall burden of the loan. Each time this is done, a newer, lower principal amount will be used in the calculation for the interest owed. It's actually called the United States rule. It says that they have to recalculate each time that you make a partial payment. They have to take it down to the new principal and recalculate on that lower principal amount. And it said it was a Supreme Court decision that specified this method, so you can read more about that if you want, but that is how it should work with all of your loans, is that every time you make a partial payment, they recalculate it with that smaller principal amount. So any amount of principal you can work down is going to help you. All right, number 10, we're going to do this. This is tons of fun. It's number crunching at its best, so I hope you like this. We're going to make a partial payment on a loan. But before we do, on A part, it says to practice using the number of days chart, if you would like, on page 577 of your textbook. And it helps you calculate how many days, because these are going to be in day increments most of the time. You're making like different payments based on smaller increments of time, so it'll be in days. So our first assignment says determine the exact number of days from August 24th to May the 11th. Now you could just get out your calculator and count those days if you like, but this chart on page 577 will help you do that. So you'll be able to look up August 24th, and you look across the top for August, then you look down for the 24th day, and it will tell you that's the 236th day of that year. And then you look at May 11th, again go across the top to May, and then go down to the number 11, and you should see 131. All right, so I'll have you check that out on your own. Well, how long would it be from August 24th to May the 11th? Well, those are in different years, so to get to the end of the year, you know, December 31st, we're going to say December 31st is the 365th day of the year. We're assuming it's not a leap year. And then minus the 236, what is that? 129 days. So we got 129 days left to go in that year. And then we wrap around in the calendar, and then May 11th is 131 days into the next year. So we'll add those days for a total of, we'll be on the 260 days total. Should be the answer on A part. So if it asks you to calculate how many days are between August 24th through May 11th, that's how you can use your calculator to help you figure out how many days that is to use in your loan calculations.